Good morning, everyone. Very happy to be here. Thank you, Professor Chow, for the very kind introduction. Can you hear me? Right, my voice is a little bit. Okay. So this one is going. And also thank the conference for inviting me up here. It's always exciting to be back to Singapore. It's very dynamic and exciting city-state. And I was talking with Hardy and Professor Chow just before the conference. And I'm also very excited to see two top universities in a very small country that is gaining rising influence, impact in the global academia. I'm just very impressed with the research and all the technological development over the years. I used to come here, once or twice, or maybe even more, every year to attend the mainly industrial conference, Singapore Summit and other conference. But it just what happened in the last few years. It just simply amazing. My talk today is not about chat GPT, and that's all I've been hearing in the last few months. And I do have a huge respect and admiration for the OpenAI team, for ChatGPT. It's just such a huge technological milestone and also engineering marvel. But that's not what I'm going to talk about here. Instead, I'm going to talk about something that is equally profound and equally exciting and equally challenging. That is autonomous driving. I will use autonomous driving and the self-driving cars synonymously in this kind of this talk. They're a little bit different, but for this talk, they mean the same thing. It is level 4 and above, meaning the cars with no drivers at all. And I use the title towards, meaning this is a journey. It is actually a pretty long journey. And last October, I sat down with the founder of Baidu, Robin Li, and then we kind of chatted about just looking at all how this started and over the years, how we invested in putting our R&D resources, putting billions of dollars into this whole thing. And we are very happy to see where we are today. And certainly research, technology, but also all the policy and all the ecosystem coming around. It's still a long journey. We're not there yet. Still, the last mile, which has a lot of other challenges, both technically and non-technically. So today I will, in the next 40 minutes, 50 minutes, I want to just spend some time looking at some of the fundamental issues in autonomous driving and also how we overcome those challenges. And I understand that the attendees of this conference are not working in this area. They're more in the search and the data mining. So I will try to stay as high level as possible. But also, I want to make sure I have a reference and details. If you're interested, I'll be happy to point you to this reference. And the work is done together with my colleagues at Tsinghua University, and also a lot of people in Baidu. Sometimes, when I use a we, I really mean two things. One is all the engineers at Baidu, and also the research and the students at the Air. Depends the time frame. As Professor Chow just said, I left Baidu end of 2019, and I started as the professor at Tsinghua University. So, just looking at the time frame, it means different things. And also, I'm happy to be back to academia because, before when I was Microsoft and Baidu, I always had to be careful. I always represented, a company or a large group, and right now I have no one else to represent. So I will now be held accountable for what I say. So I will probably spend a few minutes talk about Air. This is the institute I started in 2020, just a little bit over 2 years. And of course, well, talk about autonomous driving, looking at some of the context, looking at some of just key problems. And again, I will make sure I will have a point of view, and also my perspectives are my perspectives, and making sure it is not. It also changes over the course of when we did this work. In fact, when we started this work, we had probably just about a dozen people. Now, just Baidu, the autonomous driving Apollo team has over 5,000 engineers. So over the years, so we learned, and things have changed, evolved. Now I'll talk about our research. Our research here is mainly the work we are doing at AIR and Tsinghua. I talk about the autonomy, talk about the V2X, meaning the vehicle to infrastructure with the help from the road, from the lights, and from infrastructure. And also something I'm very passionate about is what I call RSR, which means real to simulation, to sim, and sim to real, which to me is going to be one of the biggest technical challenge, and also one of the biggest issues we face today. And it's also one of the main applications of generative AI in formulating, accelerating the whole advanced progress of autonomous driving, including, of course, robotics. And I want to leave some time, maybe 10 or 15 minutes, to have a discussion. And I'd be happy to answer any questions on autonomous driving or in ChatGPT, whatever questions you may have. Okay, so a little bit about AIR. So why and I formed AIR? I always show this chart. This has been the chart for the last probably 7 years. I first presented the chart in 2016, I guess, in the World Economic Forum at Davos. And back then, I was telling on behalf of Baidu, and we started the discussion of the fourth industrial revolution. And back then, I firmly believe that AI is the underpinning technology for this revolution. There are a lot of other things, but AI alone is the technology engine that drives the growth of the fourth industrial revolution. We are still in the beginning of this revolution. The first, which is foremost, which is the most important thing, is the digitization. If you look at the whole IT industry in the last 3 decades, the most single important accomplishment made is digitization. In fact, I started work on the first wave of digitization back in late 80s, in early 90s. That is to digitize contents, your music, your video, your imagery, your text. So that, of course, led to digital television, led to essentially internet. And then the second way was to digitize our enterprise. You have all those different database, ERPs, CRMs, all, and it eventually led to, of course, the cloud computing infrastructure. And now we are digitizing the physical world. We're digitizing the biological world. And back then, I think it was about 30 years ago, 20 years ago, Negroponte from MIT, used the word of atom to bits. Right? And now I think we are going back to atoms. We're going back to molecular. The entire physical world, our cars, our roads, our traffic lights, our cities, our home, our factories, our machines, all becoming digital. And our brains, our cells, our proteins, our DNAs, and all becoming digital. And they are all connected. And that is the power of the new wave of digitization. And that actually became the basis for the advance of AI. If you look at AI, obviously, computing power, the continued advance of new algorithms, But just the abundance of all the data sets became the whole base for this revolution. Of course, for this, we create a lot of new industries. The industry is going through a major transformation. The first one to be influenced is IT industry. New data centers, new chips, new softwares, new services. I do think ChatGPT or the big model is becoming an operating system for the cloud. It's a horizontal layer that will just, a new service, model as a service, that becoming so ubiquitous and a new infrastructure for the next wave. And we obviously is going to change our existing other industries, education, transportation, finance, manufacturing, everything we have. But also it's going to create new industries. Autonomous driving being one. The whole generative content creation would be another one. And the new life science, the new energy, this all being enabled and accelerated by AI. So that is really the backdrop why I started this new institute. We want to advance industry and the society with AI. And we want to become a global R&D center for the fourth industrial revolution. And the air has the I, has three different meanings. It's international, it's AI, and it's for industry. And the difference between this institute and others, or the academic institute, is we want to solve real problems, long-term real problems. So our biggest partners will be from industry, and it's also open. And forming a new institute from zero to one, it is hard. And the biggest challenge is people. When I co-founded Microsoft Research Asia back in, I think, end of 1998, with Kai Fu Li and a few others, that was the biggest challenge. And we were very fortunate. We were able to get some world-class scientists in the first 2 years. And that was the foundation for our success. And the same thing, we were very fortunate in the first 2 years. We're able to assemble some of the best talents, the leaders and the young talents. So right now we have 22 full-time faculties and about 200 students, postdocs, and the scientists. And I think one of the major difference, again, is our faculties, especially senior faculties, have a background both in academia and industry. You might know a few people there. William Marr, he was with me in Microsoft Research Asia, and he was the head of AI for ByteDance. And Professor Zhao Feng, same thing. He was with me in Microsoft Research Asia, and he was a CTO of Hire for 4 years. And if you look at, essentially, probably half of people used to be top researchers at Microsoft Research, either in China or in Redmond. And again, we obviously, we look at some fundamental research, but it's important that our research is linked closely with industry. That's why we build joint laboratories with companies like Baidu, Xiaomi, Didi, and also have international companies like Intel, Microsoft, and others. There are a lot of things to do. When we choose the research areas, we look at three things. One, of course, it has to make a huge impact. The second has to have a huge societal benefits. And of course, also has to fit in our expertise. So we choose three areas: robotics and autonomous driving, edge computing, green computing, and also life science, particularly in the new drug discovery. So those are the three things. I think it's still too many. We're trying to get more focused, but those are the things we're doing right now. And obviously, we have half a team work on the foundational technologies, data sets, and also the algorithms. Okay, so let me get to the autonomous driving part. So this whole autonomous driving has been around for a long time. It is a long-term human dream and ambition. And if you read the history, the dream started 5,000 years ago, and actually a real autonomous vehicle was built back in the Three Kingdom days to transport different goods and needs for the military. And obviously, it didn't work that well. I guess it's based on some of the mechanical and also the magnetic property of Earth. So it's just more of a fantasy. So more serious work actually took place back in the 80s. And it was again for military use by DARPA. And 2004 really marked the beginning of the real autonomous driving, driverless vehicle research experiment. In 2009, Google started research, later on a spin-off as Waymo. That was just a landmark in terms of just getting into the real industry, but still very, very early. In China, Baidu was the first company that started this journey back probably 2013, 2014, doing research. And then in 2017, we, when I say we mean Baidu, announced the first open commercial platform for autonomous driving called Apollo. Right now, this continues to be the largest platform, open platform that a lot of companies, a lot of car makers and OEMs use. And I actually, my only role that's connected with Baidu after I left is with Apollo. I'm the chairman of Apollo. And actually, we do a lot of work with other companies. Because this is something I've been very passionate about, and it certainly has changed the whole autonomous driving ecosystem. I have the curve, I have this chart till 2019, when I left Baidu. The last few years, there has been continuing a lot of, I would say, excitement, but also there has been a lot of consolidation, and especially some small companies went away, and things become a lot more realistic, right? And I often tell people that with media and the VC, they intend to develop the frenzy very quickly. Right? If there is a new concept, they will rush in and be excited for a couple of years, no more than 5. And then it is start of 5 years, things become real, the real innovation and the real company begin to really do interesting work, and it take another 5 years, maybe a decade, for it to become real. So in the short term, we always underestimate, short term, we always overestimate the impact of technology. And in the long term, we always underestimate. The ChatGPT is the same thing. Right now, if you look at everybody's talking about, every company is doing that. Some are real, some are not. And in a few years, a lot of companies going to go away. But it is real. It's going to take 5 years more, maybe a decade, for it to become more realistic. Same things with autonomous driving. So why are we doing this? We look at the whole automotive industry. It's been around for over 100 years. If you use the invention of Model T from Ford as the beginning of a modern automotive industry, It has been, it has become a very mature industry in the sense the technology, the supply chain, the business model has been, around, has been largely stationary for a long time. And right now we are going through a major transformation. All the technologies are being disrupted, and in all the industry we call it CASE. It's connected, autonomous, sharing, and electrified. And the key technology are very different right now. It's not the engine, it's battery. It is AI, it is internet. And all those things are beginning to just completely change the landscape of the industry. And among all those trends, and I believe autonomy is the most significant change. The reason we do that is very simple. First and foremost is safety. We want to achieve safety by at least a factor of 10, at least. Efficiency. With algorithm, you're able to park more efficiently. You're able to manage your traffic more efficiently. You want to achieve another level of 10 in the energy or transportation efficiency. And also, you're going to create a tremendous new economy. Back at Baidu, we did a study with McKinsey. We estimate $1.5 trillion of new economy, just enabled by autonomous driving. Not talking about other things. So that's why the companies, a lot more companies, new companies are getting into this new industry. Not only the car makers, the tier ones, but also ride-hailing companies, logistic companies, and the new forces in the automotives, and also, of course, the tech giants and the internet companies. So now let's look at driving. Driving actually is a very complex task, and I'm not going through this, but when we drive, then all three parts of our brains are functioning, and we need a very, very close coordination. There are 150 different functional areas, all the cells are fired up. So it is very complex. We make decisions both explicit and implicit. And you're familiar with system 1 and 2, both come into play. I'm gonna skip this, but if you map this into a more technical chart, that really you have to see, sense, you have to think, then you have to act, make decisions. That I'm not going to go into details. So it is accumulation of a lot of different technologies. And I personally believe, we had a long debate at the early stage of this work. I personally believe this is the most difficult narrow AI problem to date. However, it is bounded in the sense that it is very hard, very complex, but it is a problem that is bounded, can be solved, can decompose a complex problem into subsets that they all can be solved within a reasonable time frame. This doesn't need a very high level of intelligence. People in this room with all the PhDs, you don't necessarily have a better driving record. So it is quite different from things like ChatGPT. ChatGPT, it has to come across a lot of different domains, but you don't have to be precise. Here, it's one thing you have to do extremely well, be precise, be safe, have to make a decision impeccably. But just one thing, right? You don't have to, the software, autonomous driving software, the driver here doesn't have to understand pertain, doesn't have to write poems. I just need to do one thing well, and really well. So there are a lot of key issues in autonomous driving, both market forces and non-market forces. The market forces including the technical feasibility, user demand, industry, ecosystem, and also the business model. The non-market forces including policies, regulations, and ethics, privacy, and other factors. So we try to stay mostly on the market forces, and especially on the technology aspect. But to make this whole thing happen, all the things have to work. And even in terms of technology, a lot of things. First, in fact, in the beginning, and I was always asked, can this happen? Level 4+, meaning with no drive at all, there's no driving wheels, and can happen. And there are always two schools of thoughts. One thing can happen very, very quickly. The other thing is never going to happen. And I do believe it will work. It will take some time, but it will happen. People ask me how long. I do have a chart. I believe it will happen. Well, the happen meaning getting to mainstream. Getting to mainstream meaning 10% of the newly shipped cars. Right? So I do believe, this is back, we did a study 5 years ago. In the 2030, then 10% of newly shipped cars will be level 4 and above, which will, that I think will be a mainstream, and that I think is happening. Right now, of course, we have a lot of driverless cars running the street or in verticals, but this is still more of experimental and early commercial trials. The second is what kind of sensor you use. And there was a huge debate between vision-based and multi-sensor-based. Elon Musk, of course, from Tesla, is more of just vision-based. And I personally believe we need all of those. We need vision, which I think is probably the 80% of the sensor capability we use, but also I think we need all the other sensors. I will explain why. And of course, other questions. Do you need high definition mapping or you don't? The decision is end-to-end, or is going to be more of a component based. A lot of technical decisions. Also roadmap is going to be mainly based on the vehicle, the ego vehicle intelligence, or you also need help from the infrastructure, V2X. It is, is this going to be progressive from level 2, 3, like Tesla, to 4 and above, or you have to design from very beginning to get to the level 4. I personally believe you have to get to level 4. You design for nobody in a car. Okay. There are only two modes: people drive or car drive. But you don't have that. The thing in between just doesn't work. So very beginning, we target that particular leapfrog to level 4. And also ecosystem is going to be open or closed. Open meaning like Android, closed meaning like iPhone, iOS. And I believe both will exist. And I think open will be the vast majority. Will be probably 80%. You will have 20% that is closed. Maybe Tesla, maybe plus 1 or 2 more. Who's going to win this battle? Is the existing OEMs, car makers, or is going to be new forces, the ones I just mentioned? Actually, I don't know. It depends how the car makers, OEM, how they change. They have to make a fundamental transformation in their business model. If they don't, they will be rendered obsolete, irrelevant. But it is the new forces that have the upper hand in terms of technology. But obviously, car automotive is a very complex ecosystem, and the traditional OEMs have an advantage. The good news, they all do not invest very heavily in this technology. So let me talk about some of our research. And the first is autonomy. And I translate that very complex graph into this one. This is much easier to understand for people doing AI. And obviously we have the raw data layer, over there you have all different sensors. Could be visual, could be LiDAR, could be millimeter radar, maps, both changing, dynamic, moving objects, and also fixed structure like the road signs and the lanes, traffic lights, and also things around the roads. Then, of course, you have to making sure they work together. Right? When you have multiple sensors, the most important thing is to make sure they work together. If they work together, you may as well just have a camera. That is a key part of the machine learning. All the deep learning algorithms come into play. Then you have to, of course, have to fuse both the static and the fixed the changing and the static information. They have to make a policy, planning, make decision. And also you're going back to your platform, have a vehicle platform, the V2X platform, and they also have the simulation, the generative platform that going back and form this in the closed loop. And this chart essentially describes our vision and also our key technology approach. And we want AI towards self-driving cars. I believe multimodal perception is important. We believe map light AI navigation. Right now, essentially most of the level 4 heavily depend on the high definition maps. I think it's okay for it right now. In the future, we need to get rid of that. And we want to use standard definition maps, or we might not use maps, but that is the direction. And I do believe end-to-end decision-making and all this perception, fusion, planning, decision, and all the loop need to be end-to-end. You can't make componentized decision. That's what everybody's doing right now. Even Apollo, we are doing that because end-to-end decision is just super complex. But we have to move into end-to-end decision, and we need to use a lot of new technologies. Both the generative model, like neural fields, and scene understanding. As something just mentioned, real to sim to real RSR, and also large models. I shouldn't say language models. It is large models. It's large, can call it driving models, which I do believe this is something I've always been asked. So, should there be one foundation model compress of everything, or you need to have a vertical models, foundation models? I do believe we need both, right? But for driving, we need to have a foundation, a large scale model that is just optimized for driving. And I also believe we need to use a lot more reinforcement learning, which is really hard. In the driving, it is hard because you cannot afford to make many mistakes. And we have a team just work on offline and data-driven reinforcement learning, and incorporate that into the RSR framework. Because what happens with car is no matter how many data you have, how many test car you have, you can never cover all cases. And the worst is when you do the test drives, we have over 3,000 cars running all over the place. You collect a lot of data, and you're trying to avoid accidents. And accidents are actual data you need. It's very hard to get this. So in this case, you do need reinforcement learning to incorporate into your simulation framework and get back to the real world very quickly. And most of what do we do, except maybe one, are open source, open platform. There's one company we are still negotiating with, try to open the code. But our spirit is to open everything we do, to share with the industry, including data sets, including source code, including APIs, and that's what university lab is for. All right, so essentially, when machine drives, is the same as when human drives. We're trying to formulate a three-dimensional environmental model. Okay? And of course, with time as well. That's essentially what we're doing. Doesn't matter what sensor you use, you're trying to just rebuild that model, which of course is very hard. And not only that, you also have to predict what's going to happen in delta T, because that if you don't have a precise, accurate prediction, then your car is going to hit other cars or people. Let's see. So it is important that your machine learning algorithm is able to generalize, able to work in the case you don't have, never encounter. We call that corner cases. For those of you who are familiar with something called a sortive framework, there are 4 quadrants. One of the quadrants is the car doesn't know it's unsafe. That is the worst quadrant, because you just don't know it's unsafe. So our job is trying to minimize that quadrant. So that is essentially what we're doing. All the other 3 cases we can handle, but just the same as ChatGPT. ChatGPT, it just does not know it is untrue. That's why it starts to hallucinate and create all the things that does not happen. So there are a lot of sensors. I'm not going to go through detail, and different sensors all work together. They work together in terms of different weathers, different distance, resolutions, different sensitivities, and so they capture all kinds of different information. And some, like camera, obviously it's the main sensor. It's the main sensor for human, and it's the main sensor for cars. Has a lot of advantages, but it does have issues. Bad weather. It is passive. It is harder to form that three-dimensional, real-time three-dimensional model. It can do that, but it's harder. And bear in mind, when I see we need to reach the entire safety by factor of 10. Okay, so even machine is as good as human in terms of vision. You won't be able to achieve that. And having redundant data from different sensors, having sensed the things that beyond the vision, human vision, is an advantage. Right? So whenever there are new sensors, I say, well, just bring them along. Right? Bring them along, including the new sensor, the 4-dimensional millimeter reader, right? Which I say, well, just bring them along. Right? Because the more data we have, the more diverse data we have, then we just have a lot more capability. If you look at ChatGPT, the same thing. You're seeing all the different data, right? And obviously make sure this data have value. But you're seeing the data and then let the algorithm work. And so if you don't have those data, just have vision data as people have, it's hard to beat that, to beat human. You might achieve the same level as human, but not that. So I'm not going to go through details. We did, in the very beginning, we did achieve self-driving just with vision alone, with 10 cameras. And here, I don't know if the video works. Okay, so 10 cameras, and using, I think this one initially using convolutional code, and eventually we moved to transformer, and with the BEV forming. So then you essentially reconstruct three-dimensional objects, environments. Then of course here you need a huge computation. I think it run almost 300 GPUs just for very simple set of data. For real continuous driving, function redundancy need a lot more. And with LiDAR and other sensors in place, it's just much easier because LiDAR itself is active light, and also so it has depth information, has what I call the point cloud information, has distance information, and I can actually get to the three-dimensional objects, very classification, segmentation, detection much easier, and create semantic objects in a very short period of time with much less computation, more redundancy, and more accuracy. And of course, one argument is, oh, it's too expensive. Yes, the early generation was very expensive. One lidar initially, 16 read lidar cost almost $100,000 just per lidar. Right? That was expensive. So we pay a lot of money to Valentine and others, and every year have to change because of the erosion, corrosion from weather. You have to change to the new ones. In the last couple of years, the cost has dramatically come down. With the MEMS eventually moved to solid state. So right now it's few $100, still expensive, right? But this curve will continue. And the 4D millimeter reader cost probably 1/3, a quarter of this much. So I think why don't use that? Just bring them up. The other question I was always asked is, should this be an ego vehicle? Should all decisions be made in the car? Of course, with the cloud. The car, but also you need help from infrastructure. My answer is, well, if there's infrastructure, if you can make that work, use the data, because you always provide additional data, layer of data. The data is something that you might not be able to easily get from a single vehicle. Imagine if there's a big truck in front of your car, you're completely blinded, right? It's very hard to establish that information. But if you have a camera on the road, with a camera somewhere on a traffic light, that will give you that information, easily give you that information. So in a lot of cases, poor vision, traffic, it's a storm, or there are accidents, blind spots. The sensors from the roads, from the traffic, that give you just another global information. So that is critical. So we are using those information. However, it is important that even without this information, the car has to work, has to be function. Right? I always use analogy that ego vehicle intelligence, that autonomy is just like a driver today. This V2X thing is like a navigation, like a map to help you to make it safer and easier. But without map, without navigation, one still has to drive. So this is additional information, make it actually cheaper, simpler, and safer. Just a few examples. Unprotected left turn is one of the toughest decision for a car to make, and actually for people to make. And if you have a different perspective, additional information from the road, this become a lot easier. Another example is for example, the ambulance that coming, and they just go through the traffic lights, red lights, and if you don't have that additional information, that you may have to take a short break. If you have that information, you can just do that more gracefully. University, advantage, you have a lot of people with good math. So our PhD students, they actually build a model that one just with the ego vehicle intelligence, just has everything we had in that autonomy, and then the other one is with the help from V2X. We compare with just the safety improvement with V2X. You look at a number of scenarios and look at a lot of scenarios, but we just look at the three very, very common ones. One's car following, changing lanes, and also unprotected left turns. And you can see in the most dangerous, difficult scenarios, like unprotected left turns, actually can achieve a safety of more than 10 times. So that was the model from from the mathematical model, but also it's confirmed by the real data, real experiments we've been doing in Beijing. That is also a difference with our lab. We develop a model, but also we have thousands of cars running, and actually you can check if it makes sense. And actually, we formed a lab in the area. We formed a joint lab with Apollo, with Baidu, and we're looking at both deep learning for a single car intelligence, and also looking at how to combine the road with cars. We actually create a new vocabulary. We call the new classes of roads, just very similar to the classes, the levels of the cars. Here we also have 6 levels of roads. In the sense, in level 4 and 5, you'll be driven autonomously, but obviously we need both. This is just a way to look at the extreme case, how we leverage the roadside intelligence. And we also tested this in Beijing. I don't want to spend how much time I have. 30 minutes, okay, all right, okay. So one thing I think it is critical for the whole industry, whole robotics and the autonomous driving industry, and for us is this what I call the real to sim to real, in the sense that you of course you need to understand the semantics of sim, but also then you do all the simulation, use all the generative AI capability to augment the data, create the scenarios you don't actually get, or most likely don't get when you do the trials. Augment the data by probably 1,000 to 1, right? And then going back to real. That is very hard. Actually, in robotics, sim to real is very hard. And right now, industry and the academia, they work in parallel. University just like to use a test data set and publish papers. Industry do their own things. That is pity. Okay. We want to connect that. This is very hard, but it is important. It's critical. If you have students right now working on robotics or autonomous driving, and I suggest that you this as your research topic. I'm not going into details, but here it is. It's very similar to reinforcement learning. Right? Essentially, you have your reward function not only from your simulator but also from the real world. Right? So you make that connectivity. I will just. I'm gonna skip this. This is actually one of the open competition we sponsored as part of ICRA and also maybe CVPR, and actually doing exactly that. This is much simpler for experimental robots. Let me skip that. And again, this is the entire, the things we try to do: understand the thing, identify the system, optimize, doing all the generations of data and the scenarios. And when you finish that, you have to deploy back into your robotics or your machine or your cars. And it has to be closed loop. You can't do, one thing at a time. It has to be end to end, has to be closed loop. Otherwise, things will drift. The things you do will make minimal impact. I'm going to skip this. This is just I ask my students to, each give me a just what they do, the description, and they give me like 50. I just select a few. Each of those was just published last year or going to be published this year, including the scene understanding, both the environment and also the objects, including how you're going to amend and make up all the data for example, LiDAR. And we will run into distance, the far distance, for example, 100 meters, the data become very sparse. And how you're going to make up the data. Also for 4D radar, the data become much sparse. And also, when the car drives in the evening, and how you're going to make sure that still works. And here I think using the 4D and the NERF, neural radiance field, to rebuild that scene graph, and also you're trying to make sure you can deploy back to your environment, both from simulator, that's the sim to real to this is the sim to real part for robotics, and also for the cars. And each of this probably has a few papers. If you're interested, I can always ask student to send to you. Let's skip that. And I do want to mention that we have an open platform that you can use to try the things. And, it's a ROS based and also has an Apollo interface. So this is open to academia, to everybody actually. All right, so I will spend the last 5 minutes talk about this is critical, that how we actually deploy this. Because you can do all this fancy work in the lab, in the publish papers, but it is important we make this real. Right? So first thing we did is we need to make sure we have a real data set. And the data set, so we actually created the first open data set for car and V2X. They have to, all the data have to be aligned spatially and time-wise. That is important. So this right now is available, and I encourage our Singapore colleagues to use data. And right now I think right now 70,000 frames. Right now we have a lot more. And the other thing, of course, is to do the experiments. China has, this is one thing I think China policymakers doing extremely well, is to have a top-down structural plan to designate some of the cities as kind of double intelligent cities, intelligent vehicles, intelligent city. And particularly in Beijing, this is both for existing vehicles, right, and also the new ones, the one that there's no level 4, level 5. And this is for bus, for ambulance, for different type of vehicles. And particularly in Beijing, Beijing actually boasts I think the most advanced, the largest scale autonomous driving region in China and in the world. And last year, it has 70 square kilometers of area in Yizhuang, and also with I think 100 kilometers of highway. And right now, this is expanding to the entire city of Beijing. And I want to use this chart to end the talk, maybe one more video. Really use Apollo as how this advance, how this progress over the years as the indication of autonomous driving progress in China. And we started this 2017 open source, and last year we already finished almost 40 million kilometers of trials with thousands of cars running, again with $1 billion invested. And it's working really well. And also it began a commercial, I would call it trial, commercial operation in small scale. We charge people, you have to pay a fee, probably half of your taxi. And also in the last year, you don't need people in the car. You don't need the safety drivers. And that is getting real. I always tell the policymakers that in order to make it happen, you have to make it happen. Don't put the people there. You just have to. We are very confident in our technology. But obviously, we need a lot of more testing, real testing, and a commercial operation to make this a real reality. So let me use this video. This is 10 million. This was our first trial. Actually try it for different classes. For different weathers, evenings. So we achieved that milestone about 2 years ago, 10 million kilometers. There are only maybe 2 companies that achieved that milestone so far, maybe 3, I'm not the third, but Waymo, of course, being the first one. So let me use this to end my talk. It is autonomous driving is a long-term human ambition, a dream, and we have to make huge investment, be patient, be relentlessly focused to make this happen. And we are still at a journey. It has not happened yet, but I believe it will happen soon. And as academia and the industry, we all need to work together to make this happen. Thank you.